Today we're going to talk about attention is all you need. It's based on the paper that the engineers from Google presented in 2017 about a new technology at that time that become the actually what the industry is using and made possible applications as the ChatGPT and others in NL. By the name of the by the time of the presentations are in long short-term memory and gate and where those established in sequence modeling and transduction problems. However, this sequence take a memory and it takes a long time and cost in all the applications. Attention mechanism has become an integral part of compelling sequencing, modeling, and transductions at that time. So the engineers at that time present and propose this new model architecture called the transformer. This avoid the recurrence, relying entirely on those attention mechanisms. The background, the existing models all were based on sequential, like a standard neural GPU by net and S2S, all use convolutional neural network, and the number of operations to relate distant inputs and output grows linearly from all those using S2S and logarithmically for by net. It make difficult the learning of dependency between distant positions. The transformer, it reduces the number of operations, and because it averages the attention weight positions to reduce all that complexity. The reduction of effective resolution when doing those average positions, it lets some it's compensated for accuracy with the multi-head attentions. Self-attention is an attention related to different positions and a sequence in order to make us faster represent those sequences. Transformer was the first model at that time that entirely it used only self-attention models. As I said, it was presented in 2017. At that time, the RNN and other methods were the most they were the state of the art, but they produce, of course, constraints for the limit on the batching across all different examples. Attention mechanism has starting to become an integral part of compelling sequencing modeling and transductions, and they basically create the transformer, which is the architecture that they present at that time, which was proposed, which relying entirely on attention mechanism, it avoid completely the recurrency. And those with the attention, they draw global dependence between the input and output, which allow significantly more calculus at the same time or parallel calculations. About the model architecture, all the best models at that time and currently they basically have the same architectures, encoder and decoder, encoder for the output of the input and decoder to generate an output. But in this case, they use stack self-attentions and 0.1 fully connected layers for that encoder and decoder. So we can see here how we have two layers for the encoder and then three layers for the decoder. Decoder stack, it has six identical layers, or that's what they proposed at that time, or they used, and each layer has two sublayers. The fifth layer has a multi-hepside attention mechanism, and the second layer is a simple, just a fully connected feed-forward network. Residual connection was employed around each of the two sublayers, adding the normalization, those layer plus normalization. In the case of decoder, it's a very similar architecture, but it was added a mask multi-head attention. And part of this is prevent positions from attending to subsequent position. This decoder take the output of the encoder, and this masking combined with the fact that the output embedding are offset by one position ensure that the prediction for a position I can depend only on the node output at position less than I. So basically it's gonna keep learning from previous positions. Now, what is attention? Attention function can be described as mapping a query and a set of key values pair to an output. We have the query, the key, and the values, and outputs all the vectors, and those are compute for the sum of weight of all value. So basically, it generates three different sets of to give the importance of each token or word for the position of the word, and finally to make a match with the output. We have two different types of that were presented at that time of attention: the scale dot product and the multi-head attention. The scale dot product attention is a basic attention, and it consists of the same queries, keys, and dimensions of the k and values of dimension of the value. It computes the dot product of the query with all the keys, divide by the root of the k, and after that it takes a softmax function to obtain the weight on the values. In the practice, they compute the attention function of set of queries simultaneously, packed together into a matrix cube. It's a maker, of course, faster, since it can do all the depending on the GPU GPU, of course, but it can make different calculations of those and word or token at the same time. Then we have the multi-head attention, and instead of performing a single attention function with dimensional key value and queries, the group found beneficially linearly projected queries, keys, and value a number of each time with different learned linear projections to decay and dimensions respectively. Of each of these projected versions of query, key, and values then perform the attention function in parallel, producing multidimensional output value that are concatenated after to get to the solution. Now we can see that it has some advantage in the calculations, but why the self-attention? To be more clear, the total computational complexity per layer. Uh, a self-attention layer connects all positions with a constant number of sequentially executed operations. Whatever a recurrent layer requires an order or n sequential operations. In terms of computational complexity, self-attention layer are faster than recurrent layers when the sequence length n is smaller than the representation dimensionality d, which is basically the case on the transaction problems. A single convolutional layer with kernel with k less than n do not connect all pairs of input and output position. For that, it will require a stack of the order n over k convolutional layers. In the case of contiguous kernel, or in the case of the dilated convolutional, the logarithm of k over n. The path length between long-range dependency on the network is much shorter in the case of the self-attention. And one, not only the amount of computations, and the computation is shorter, but it can be do parallel, taking advantage of the GPUs. And another extra is that it is easy to interpret the models much easier than the convolutional network that actually doesn't make any sense through the calculations, except when it gets to the results. Now let's talk about the training that they did at that time. The training was performed on a standard English-German data set with 4.5 million sentences using a NVIDIA Tesla P100 GPUs. They did a basic model for 12 hours and a big model that took 3.5 days to train. They use the ARM as an optimizer. The learning rate for the first step increased linearly. They were changing it. And then it decreased, they decrease it thereafter proportionally to the inverse square root of the step number. They use 3 types of regularization: the residual dropout of each sublayer before it is added to the sublayer input and normalized, dropout to the sum of the embedding, and the positional encoding. Embedding is always necessary to before these layers of encoders, decoders, and label smoothing. It hurts the perplexity, but actually improve the accuracy and the BLU score, which is the score used for these types of model. Now the results for actually compared to the existing state-of-the-art models existing at the time, it report a better score, more than 2.0 PLU, which was stable as a new state-of-the-art with a total score of 28.4. Not only this, but the timing that it took, it was a fraction of what the other models used to take at that time. I hope it will help, and thank you very much.